No, not that camera. Come on. Come on. There it goes. Okay. So again, it said that it was 3.67 miles to your grandparents' house. And you're walking at a slow jog of 4 miles per hour. And it's like a brisk walk, not running, 4 miles per hour. And they want to know, how long does it take for you to make that? And there's a bunch of different ways that you can approach this. I've seen 4 methods, like I said earlier, that that I've seen students use to solve. I think probably the most solid one would be to think of this equation, the dirt equation, or maybe your teacher taught it to you like this, where distance equals rate times time. And in our case, we have the distance and we have the rate. So we divide those two to get the time. And that's probably the one that I think is the most straightforward. So our distance, 3.67 equals our rate, which is 4 miles per hour times time. And then of course, you divide by 4. And then that will give us, one was yesterday. 1 was the 10 questions yesterday. 2 is these 4 questions, and then 3 has a couple questions after that. Yeah. Did you write down the stuff from yesterday? Okay, good. All right, so what do we get for time? Time equals, what'd y'all find?
0.91.
0.91? There's no more decimals?
75.
Oh, okay, so it could be rounded to 92. Okay, so 0.91, 75, that would be our hours, right? They asked for hours. Now, how do I convert hours to minutes? Divide by 60, so 91.75 divided by 60. Multiply by 60. See what I'm saying about having a number in mind? We know that it should be close to 60 as an answer. So times 60 would get us 55.05. And they said to round to the nearest minute. So minutes. All right, and that's showing work right there. This part right here is showing work. Now that's one way to solve it, and it's a way that works. D equals RT. I've seen students use several methods, like what I told you about cross multiply and divide. They'll say like, okay, it's 4 miles in 1 hour, so 3.67 miles in X hours, and then they would cross multiply and divide, and that ends up doing the same thing. 3.67 divided by 4. When we cross multiply and divide, it's the same thing. Or I've seen some kids, as some have said, go big brain and go 4 miles in 60 minutes equals 3.67 miles in X minutes. And they just go and skip the whole hours thing and go cross multiply and divide. And then they do it all in one step. So there is always a lot of methods to approach something. I recommend knowing them all, but I recommend, working with what your mind says, oh, I get it. So I think probably the easiest thing to remember is basic equations, or to remember about doing cross multiplying and dividing. Of course, you don't need to write all this down. I'm just trying to show you different ways students have approached it and gotten to 55 minutes at the end. It all ends up becoming the same math steps, but the question is, how do you set it up so that your mind says, oh, that makes sense to me? All right, let's look at B. I'll read it to you so that we can leave the screen on. B says, if your average stride length is 2.6 feet, so 2.6 feet equals 1 stride. A stride is like walking, like how far apart your feet are as you walk. And when you walk, your stride is closer together. When you run, your stride is further apart. So think of it like steps. Basically, we're trying to figure out how many steps you need. If your average stride length is 2.6 feet, how many strides will it take you to walk to your grandparents' home? Hint, you will need 2 conversion factors. So how am I going to do this? We've got these 2 pieces of information, the length of the stride, the distance walking. What else do I need to get to the answer?
Need the time.
The time? Well, isn't that, no, we don't need to know the time, because we're just trying to find, we know the distance and we know what each step equals. So we don't, time isn't really a factor here. It doesn't matter how long it takes. We just want to know how many steps in the end. I do need something from my conversion chart. Look at the units that we have in our equation, or what we have, I mean, in our sentence. We have miles, we have feet, we have stride. How am I going to relate miles to feet?
Every mile is 5,028 feet.
Yeah, 1 mile is a distance of 5,280 feet. I need to know how those units are connected so that I can go from miles to feet to relate to the strides. So I'll write that down, 1 mile, since it's kind of hard to see on that paper. Now you can use the cross multiplying thing like I said. I want to show you a method that I like to use the most, and it's like this little kind of table I set up. And this is the way I learned it, I think, in my like chemistry class or something like that. And I've always used it since. But I've got 3.67 miles. And I know that 1 mile is 5,280 feet. And I know that 2.6 feet are in 1 stride. Now, what this table does is it's multiplying a bunch of fractions together. So I know that there's a ratio of feet to miles here and a ratio of stride to feet here, and a multiplier at the beginning. Everything at the top is multiplied by each other, and everything in the bottom is divided from the top. And what that does is I use it to set up that all my units cancel out, and I'm left with the unit I want, because ultimately I want to know how many steps he's taking, or strides. So anything divided by itself, because everything on the bottom is division, everything on the top is multiply. So multiply, multiply, divide, divide. That's what this means. So miles divided by miles cancels out, because 5 divided by 5 is 1, right? Anything divided by itself is 1, it cancels out. Feet divided by feet cancels out. I go from miles to feet to strides, which is what I want to do at the end. This is the method I like to use if I have multiple steps. You can go on and make a whole bunch more to this if you have to convert, like 5 different times, and it's all multiplying and dividing. And it really helps you make sure that you're not screwing up your units, which is important. Because you don't want to end up multiplying by things, and then what you end up realizing is you're doing like miles squared instead of, canceling out miles to get feet. And then that's not a unit we're using. So this ultimately means 3.67 times 5,280 divided by 2.6. That's what this ends up meaning. You could do either one of these to show your work. So we multiply those, and what do we get as an answer? 3.67 times 5,280 divided by 2.6. What do we get as an answer?
$7,452. Is that right?
7,452, yeah.
And then 0.92.
Oh, 0.92? Okay, so then 7,453, because you can't have like part of a step. You got to like make, a full step. So there we go. Good. $7,453. Remember, as I said yesterday, you've got to show your work. Maybe you're the type of person that likes to write out your conversions and what you have at the top. I don't typically, but I do it so that students know what I'm doing. Maybe you're the type of person that just likes to type it into your calculator and not write it down. That's not a good method, by the way. You got to write them out. So whatever you type in the calculator, if you're like, oh, sir, I did this times this divided by that, then just write this. If you're the type of person that hates writing work and you just put in your calculator, all I expect from you is a minimum this, if you've got it. I will say, you got to get in the habit of writing work out. I remember when I started taking my engineering classes, the calculations were getting so intense. The amount of values that I had to type in the calculator was becoming so much. If you didn't write your work out, you would forget what you were typing in the calculator if you were using a scientific calculator. I actually had to go and get a graphing calculator so I could see the entire equation that I was typing out. So I think it's extremely important to write out your work as an engineer, as a scientist. The stuff only gets more complicated. Yeah, go ahead, Nehemiah. So B is done. Now I'll move to C. C, I want you to work on your own. C is exactly like A. The only thing that changed was now he's on a bike, which means he's moving faster. The distance is the same, the rate has changed. So I'll put C up on the screen. Here. So try C on your own. If you ride a bike an average speed of 15 miles per hour, how long will it take you to ride to your grandparents' house? It wants you to give an hour and then convert to minutes. So you have all that you need to do that. You're trying out C. You're doing the same relation to distance equals rate times time. That same equation. Or you can do a cross multiplier. Yeah, it takes up more space, doesn't it? They're taped down too, so I don't think you can pick them up. Does it make you feel claustrophobic? Does it make you feel claustrophobic? Yeah, yeah. Mason looks like he's gaming again. How does Mason see? He's got like some hair in his eyes. I don't know.
Yes, sir. I got a ton of hair in my eyes.
Yeah. Yeah, Johan, that's good. But remember, it does say to round it to the nearest minute. So I think you got the right number. You should expect it to be much faster. You should be have a much smaller amount of minutes compared to A. So, y'all ready to move on to the next one? Don't forget, when you can, please change your profile picture to have your face, not a random cartoon character or your no face.
Yep.
Try
So
to
you
add
realize
a
we
profile
so,
picture.
so you realize we can't even put our own face on our things?
Huh?
You can't put your face on your thing. Like
What do you mean by?
Because we're, at least for what I know, right, sir? Because I was in world geography, and then the principal's in there, and then she started getting mad at kids because they had like pictures of their faces instead of just their name.
No. She's mad that you didn't have your camera on.
Well, no, sir, because it was the kids that had iPads, like they were doing work, and then she mentioned that you can't have a picture on your thing; it can just be the name.
I haven't heard that. Have you heard that? I haven't heard that they can't have a picture of their.
There's some teachers say you can and others say you can't. Like it really just depends on what teacher
On the
you have.
district policy, the little paper thing, it doesn't say anything about it. It says always have your camera on. But I mean, I'm never forceful about that because students are in different, positions in life. So I don't want to stress anyone out. All right, let's move to the next question. Let me do share. Come on. I don't know why it takes a while to find this camera better. You can do it. Talk faster to each other. There it is. Okay. So C you're doing on your own, like I said, of course. So now I'll move to D. You should have gotten like a fourth of an hour, around 15 minutes. So this next one here has multiple conversion steps. If the circumference of each wheel on your bike, so circumference is 82.6 inches, how many revolutions of a bike wheel will it take to get to your grandparents' house? The reason why circumference is important is like if I took a wheel and I painted it and I moved it forward, it would make, I guess this desk isn't very flat. It would make like a line on the ground, and circumference ends up becoming distance moving forward. Every time the wheel moves forward 360 degrees or one rotation, it moves forward 82.6 inches. That's how circumference becomes linear distance. This type of relationship is how cars and their odometers work, how they calculate how far you've gone forward. They don't use like GPS or anything like that. It's like gear relations and rotations that it's working with. So we have that. We have our distance of 367 miles, right? And that's all we're given. It's not about time again. We're just trying to go from, it says how many revolutions of the bike wheel will it take to get to your grandparents' house? So how many times is the wheel going to spin? Give your answer to the nearest revolution. So they want a whole number. Hint, you need to convert miles to inches and create a conversion vector to convert inches to revolutions of a wheel. So our 1 mile equals 5,280 feet, right? And then, of course, you're going to need that 12 inches is 1 foot. Goes without saying, I would say. So let's convert this. I'm going to use that long chart. I got 3 steps I need to do. I have miles, and I want to convert miles. 1 mile is 5,280 for feet. Miles cancel out. And 1 foot is 12 inches. Feet cancel out. And inches now at the bottom, 82.6 inches is 1 revolution or rotation. Inches cancels out. See how every unit cancels out? I put the next unit at the bottom and the new unit on the top. So I can go from miles to feet, feet to inches, inches to revolutions. What does this look like? If I were to work it out without my table, you would do this times this, times this, and then divide by 82.6. Those would be the steps that I would take. Multiply, multiply, divide. Some students do it in different methods. They'll say, okay, they'll just say this many feet in a mile and then convert miles to inches by multiplying these two. And then they'll go back and multiply by this, and then they'll divide by that. And that's fine. Whatever helps your brain understand how to approach the problem is good. You just got to think it through. This just organizes it all in one thought, and which is why I like to use this method. Why I like to use cross multiply and divide, because it organizes them in the correct location so I don't screw up. And I make sure that I do it correctly, you know?
So how would you do this in the cross multiply and divide the
You
fractions
would do
version?
multiple cross multiplies and divide. So you would do 1 mile and foot in one thing, and then mile and then X feet in the other. But miles, like they would have to be, this would be flipped. If you were to do a cross multiply and divide, then you would say like 1 mile, 5,280 feet equals 3.67 miles and X feet. Cross multiply and divide. And then that answer would go into another cross multiply and divide. So you'd end up doing cross multiply and divide like 3 times. And it's doable. As long as you put everything in the correct order, you should get the right answer. For single steps, I like to do this. For multiple steps, I like to set it up here so I feel very organized and less likely to make a mistake. Because I know that everything is going to cancel out if I do it correctly. So it's just a good way of organizing your thoughts. What did you get for the answer? You said 2000 what? Yeah, that's good. Yeah, so it's 2,815 to the nearest revolution set. Yeah. All right, the next number 3 is actually pretty fast. What time is it? 5. Bell's going to ring in 3 minutes. You can do number 3 on your own. I'll fly through it tomorrow. It's actually really easy to do. So help me remember to do 3 with you tomorrow if anybody has questions. It's actually pretty easy.
Sir, when is this due?
It's due today, but I mean, if you don't do it today and you have questions tomorrow and you re-upload it tomorrow, that's good. I'm not going to check them today anyways. I'm still going to look back at your notes that you submitted yesterday first. I should probably shift the due dates on this to where they're all due Friday or something. So don't get hung up on the due date. Just make sure that you get it in at a day or two after we do it.